This is the first problem of the midterm examination. To solve this, we proceed like this. We consider this is the feedback impedance ZF, and this is the input impedance Zi. If we represent the system in the Laplace transform, it is easy for us to write down the V output T as VO, V output S as a VO S, and VIT as a VI S. Resketching the circuit will make the things more visible. So this is the operational amplifier, and the feedback impedance is ZF. The output voltage is Vout S. The input voltage is VIS, and the input impedance is ZI, and here it is ground. In the ideal operational amplifier, we studied the characteristic that the voltage at this node will be the same as the input voltage over here. So here I can write VIS. This circuit is known as non-inverting amplifier. But fundamentally, you do not have to memorize the input-output transfer function for the system. Using the basic characteristics of the ideal operational amplifier, we can write the approximate circuit like this. The output impedance, the output voltage, the input voltage at the node VIS, and the input impedance ZI, and it is connected to the ground. It is straightforward to use the potential divided rule to write down VIS is equal to input impedance upon the sum of the input and the feedback impedance multiplied by VOS. This can be rewritten like this: VOS upon the input impedance VIS is the transfer function of the system TS, which will be equal to ZI plus ZF upon ZI. The remaining job is to find out the values of the input and the feedback impedances on the next. So now we can determine the transfer function. The input impedance is ZI, and the feedback impedance is the ZF. So it is straightforward to write the input impedance ZI is equal to 400 kilo ohm. So it will be 400 into 10 to the power 3 plus 1 over 4 into 10 to the power minus 6. This is for the 4 microfarad, and we write over here the Laplace variable S. Then simplifying this equation, it is easy to write 10 to the power 4 into 40S plus 25 upon S. Similarly, Z output, ZF, the feedback impedance, is equal to 110 into 10 to the power 3 plus 1 over 4 into 10 to the power minus 6. and the Laplace variable s, this is for this 4 microfarad. Then simplifying this will be 10 to the power 4 into 11s plus 25 upon s. Therefore z input plus zf, like the feedback impedance and the input impedance, is equal to 10 to the power 4 into 51 plus 50 upon s, and the transfer function t of s, v output s upon v input s, will be equal to the impedances, sum of the input impedance and the feedback impedance upon the input impedance. It is easy to write down 51s plus 50 upon 40s plus 25. To write this in the standard format, it is easy to write upon 40s plus 5 upon 4 divided by s plus 5 upon 8, and this is the transfer function of the system. So the answer of the given question in the examination will be somehow like this, and it is in the standard format. Just to remember this, this circuit is the non-inverting amplifier, but you don't have to memorize the transfer function of the system. You can always determine the transfer function using the basic ideal characteristics of the ideal operational amplifier. Thank you very much.